Hi everybody, I'm John Quinton from Lancaster University, and I just want to introduce this learning activity to you. And we're going to focus on the measurement of saturated hydraulic conductivity. So I'm going to try and do three things here. The first one is to tell you something about the soil infiltrometer. That's a piece of equipment we're going to be using in this activity to measure hydraulic conductivity. I'm going to be getting you to think a little bit about why we might want to make hydraulic conductivity measurements. And then I'll give you a bit more detail on some of the elements of this learning activity that I want you to work through. So let's start by having a look at an infiltrometer. It's a pretty basic piece of equipment. Hopefully if you're at Cabianga, they should have one there for you to have a look at. But I've got a couple of pictures here, a diagram and a picture of one in the field. And you can see they consist of a metal ring which is driven into the soil and then a reservoir tube above it which provides a reservoir of water which is going to move through that ring and into the soil. And we're interested in how fast that water moves through the ring so that we can calculate the hydraulic conductivity. You may have done measurements where you've taken cores back to the laboratory and measured the hydraulic conductivity of those cores, and this method is a very similar approach, but rather than take the cores away, we're going to measure them in the field so that we have something which is perhaps closer to field conditions than it might be if we disturb the soil and remove a core. So using the permeameter, we can calculate the saturated hydraulic conductivity. So this is classically defined as the discharge of water through porous media per unit of hydraulic gradient and cross-sectional area through which the water is flowing. We use Darcy's law, which is transformed, and we have the equation which is here on the slide. So Ks is the saturated hydraulic conductivity. That's what we want to calculate. Q is the reservoir discharge through the soil core, here in meters cubed per second. A is the cross-sectional area of the soil core, so that's the bit that's been driven into the soil. L is the length of that soil core, and DH, the change in the hydraulic head between the inflow and the outflow ends of the soil core. Once we have all those values, we can calculate saturated hydraulic conductivity. You'll often find that the term permeability is used interchangeably with the term saturated hydraulic conductivity. And you can read about this in a paper by Nick Chappell and Les Ternan, Ring Permeametry Design and Operation and Error Analysis. And you'll find a copy of this paper associated with the exercise. So I encourage you all to read this before you go on to any of the following videos. So what I'd like you all to do now is just to spend a few minutes thinking about some of the reasons why you might want to make hydraulic conductivity measurements, and perhaps you could discuss those with your colleagues, either virtually through the Moodle site or in person if you're together in the workshop space. So hopefully you've come up with a number of ideas. Perhaps you decided that trying to understand runoff generation processes was one of them in terms of why you might want to make infiltration measurements, and you can see some runoff here and on the edge of this slide. So what I would like you to do now is to, if you haven't already, read the Chappell and Turner paper. Then have a look at the video we've made on how to make infiltration measurements, and have a good read of the instruction booklet that is associated with that video. If you've got the opportunity, if you're at Cabianga and you can have access to the equipment, you can make some measurements using the equipment, and then watch the video on soil infiltrometer calculations. And you'll find that we've attached a spreadsheet for you to be able to fill your data into, and you'll be able to calculate the saturated hydraulic conductivity of your soil. So I hope you enjoy the learning activity, and hopefully by the end of it you'll have a good feeling for how to make some saturated hydraulic conductivity measurements in the field.